Back. In this video, we are going to solve problem 5.26 that is taken from Mechanics of Material Beer and Johnston 6th edition. So statement is knowing that W is 12 kilonewton, draw the shear and bending moment diagram for beam AB and determine the maximum normal stress due to bending. So you can see this is beam AB having point load at C which is 8 kilonewton and at E it is 8 kilonewton. A weight of 12 kilonewton is suspended uh, through this pulley and this is acting downward. As a result, this rope will exert a force upward which is 12 kilonewton acting on that. And the cross section is shown over here. This is wide flange beam which is W310 by 23.8. So you have to determine the shear and bending moment diagram. So let's start with the solution. So first step is that if you remove this pin support at point A, so you will be having a vertical reaction force which is AY, as well as you will have a horizontal reaction force which is AX. And similarly, if you remove this roller support at point B, so you will replace it with a vertical reaction force which will be BY. Clear? So we'll find this AX, AY and BY by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along X direction must be equal to 0 and force toward right is taken as positive. So AX is acting toward right and there is no other horizontal force. So it means that AX is equal to 0. Now we'll find this another force which is you can say AY. So for that we will take sum of all moments about point B is equal to 0 and taking the counterclockwise moment as positive. So you can see this weight which is acting downward will exert a vertical force on this rope. This rope will exert a vertical force on this beam, and let this force is represented by 12 kilonewton. So now we will apply this equation. So sum of all moment about point P is equal to 0. So first moment is due to this force and perpendicular distance is 1 meter and this is counterclockwise, so it will be positive. So I can write over here that 8 kilonewton multiplied by 1, that is positive. The second moment is produced due to this 12 kilonewton load and perpendicular distance is 2 meter and it is producing clockwise moment, so it will be negative. So I will write minus 12 times 2. The third moment is produced due to this 8 kilonewton load and perpendicular distance is now 3 and this is also counterclockwise moment, so it will be positive. Plus 8 multiplied by 3, and the last moment that is produced due to this AY and perpendicular distance is 4 and it is producing clockwise movement, so it will be negative. So minus AY multiplied by 4 is equal to 0. Okay. Now we will find this AY. So 4 times AY will be equal to 8 minus 24 plus 36, and we will get here is that this will give us plus 12, 8, 20. Okay, so you can see 8, 3 is 24, not 36. So I will correct it. So this will be 24. So plus 24 minus 24 will cancel. So we will get 4 times AY is equal to 8. And from here you will get 8. AY will be equal to 8 divided by 4, which is equal to 2 kilonewton. Now we'll find the last unknown, which is By, that can be obtained by using the third equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So AY, which is upward, so plus 2 minus 8 plus 12 minus 8 minus 8 plus 12 minus 8 plus By is equal to 0. Okay. So you can see this 8, 8 minus 16 plus 12 is minus 4 plus 2 is minus 2. So By will be equal to 2 kilonewton. Now you have all these reaction forces. So we will able to move to draw the shear force and bending moment diagram. So for that, I will take the vertical line from the end of this beam in order to draw the shear force and bending moment diagram. So this is the vertical line. First we will draw the shear force diagram. So for shear force, I will take a horizontal line to show length x in meters. And on y-axis we have shear force having unit kilonewton. Let each division is equal to 2 kilonewton. So 2, 4 and 6. Similarly -2, -4 and -6. Okay, starting from point A, you can see at A we have AY which is 2 kilonewton. So I will draw 2 kilonewton. So this will be your first point. Now moving from A to C, there is no other force, so it will remain horizontal till point C. So I will make it horizontal till point C. Let this is your point C. Okay. Now you can see at point C we have -8 kilonewton. So 2 minus 8 will give you -6. So shear force will change from 2 to -6. So I will draw vertical line from this. So this is -6. Now moving from C to D, there is no other force. So it will remain same and we will get a horizontal line till this point. But at this point D, you can see you have a 12 kilonewton load. So -6 plus 12 will give you +6 at this point. So shear force will change from -6 to +6. This is +6 kilonewton. Now from D to E, again there is no load, so it will remain horizontal. So from this D to this E, it will remain horizontal. And at point E, you have -8 kilonewton load. So 6 minus 8 will give you -2 kilonewton. So shear force will change from this to -2 kilonewton. This is your -2 kilonewton. And moving from E to B, there is no other load, so it will remain horizontal. And at the end, you can see you have By, which is +2 kilonewton. So it will make this upward to the 0. So from this, you can conclude that you have drawn a correct shear force diagram. Now, we will move toward the bending moment diagram. And for bending moment diagram, you have to draw a horizontal line to show length in meter, x in meter, and on y-axis you have moment which will be kilonewton into meter. Okay, so what we will take is that we will take this one division is equal to 2. Clear? So 4 kilonewton into meter. Similarly, -2, -4, and this is -6. Okay, starting from first point, at first point you have at point A, as x is equal to 0, so moment will be equal to 0. Now the shear bending moment is actually the area under the shear force diagram. So you can see the first area under the shear force diagram is this one, this A1. Clear? And this A1 is equal to this height, which is 2, and the length, which is 1. So 2 multiplied by 1, which will give you 2. So first your point will be this 2 at this length. So you will get this point. I will choose blue color. This is your first point. Now you can see that shear force is a horizontal line with 0 degree and bending moment will be 1 degree higher. So it will be a straight line and slope will be increasing because this area is positive. I will draw this vertical line from this, straight line. Now the second area is this area which is equal to A2, and this A2 you can see this is equal to this height which is -6 multiplied by length is 1. So -6 multiplied by 1 will give you -6. Okay, so here we have 2 kilonewton. So 2, this 2 minus 6 will give you -4. So -4 will be at this point, your bending moment will be this one, -4. And again you can see you have this shear force is a horizontal line with 0 degree, so and this area is negative, so bending moment will be 1 degree line and the slope will be decreasing, so you will get this straight line. Okay, let me join these 2 points. Okay, now the third area is this A3, and you can see this A3 is 6 multiplied by 1, and this is positive, so A3 is equal to 6 multiplied by 1, which is +6. So -4 plus 6 will give you +2 at this point. So you will get the bending moment at this point will be like this. This is +2. And this shear force is a horizontal line with 0 degree and A3 is also positive. So bending moment will be 1 degree line and slope will be increasing. So you will get, you can join these 2 points. So you will get this. Okay. The last one is this A4. So A4 is again, you can see this A4 is equal to -2 multiplied by this length, which is 1 meter. So it will be -2. So +2 -2 will give you 0 at this point. So again, the shear force is a horizontal line with 0 degree and this A4 is negative. So bending moment will be 1 degree higher and slope will be decreasing. So by joining these two lines, you can complete the bending moment diagram. So what I can write here is that this is BMD bending moment diagram and this is shear force diagram. Okay, this was our first part. Now in second part, we have been asked to determine the maximum normal stress due to bending. As we know that maximum normal stress is equal to maximum bending moment mod divided by the section modulus. So you can see here that maximum bending moment, absolute value of maximum bending moment is -4 kilonewton into meter mod. That will give you 4 kilonewton into meter. And what about x? Since we have been given that this is W 310 by 223.8. Clear? So from the table, let me show you. I will go toward the table and we will select the W 310 by 23.8. So you have to go to the property of rolled steel in appendix C. So here you will choose the SI units. Okay, so W310. Okay, now you can see here that this is W310, but 23.8 is here. So what you will get is that you will get this SX, which is 280 into 10 to the power 3 cubic millimeter. So 280 into 10 to the power 3. SX is equal to 2, SX is 280 into 10 to the power 3 cubic millimeter. And if you convert it into meters, so Sx will be equal to 280 into 10 to the power 10 to the power 3 multiplied by 10 to the power minus 3 power 3. And this will be cubic meter. So that will give you 280 into 10 to the power 3 into 10 to the power minus 9 cubic meter. And at the end, it will be 280 into 10 to the power minus 6 cubic meter. Now you have both the value, just use it. This formula, maximum bending stress is equal to maximum bending moment, which is 4 kilonewton. So 4 into 10 to the power 3, it will give you Newton divided by Sx, which is 280 into 10 to the power minus 6 cubic meter. Okay. Cubic meter. And this one is Newton into meter. So it will cancel Newton. 1 meter will cancel with that. So you will get 14.29 into 10 to the power 6 Newton per square meter. That will be the maximum, absolute maximum bending stress. So maximum bending stress in Pascal will be 14.29 into 10 to the power 6 Pascal, because Newton per square meter is Pascal. And if you want to convert this into megapascal, so maximum bending stress is equal to 14.29 megapascal, which is the answer of our second part. And that is all about this problem 5.26. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.